Now I want to explain you one of the example with the help of results how to calculate the surface area and the total perimeter of cuboid. The question is, a small indoor greenhouse herbarium is made entirely of glass panes, rectangular pieces of glass, including base. Base is also of the glass. The length, breadth and heights are 30 centimeter, 25 centimeter and 25 centimeter. Find the area of the glass required to make this herbarium and length of the tape needed for all 12 edges. That is, first I want to write in the solution. That length of cuboid. Length of cuboid is given how much? 30 centimeter. Then breadth of cuboid is 25 centimeter and height of cuboid is 25 centimeter. Because all 6 surfaces of the cuboid are made up of the glass, so I want to calculate the total surface area of all 6 faces. Surface area of cuboid. Surface area of cuboid is given by the formula 2 into L into B, B into H plus H into L. So this becomes twice of length into breadth, 30 into 25, breadth into height, 25 into 25, height into length, 25 into 30. So this becomes 2 into 750 plus 625 plus 750. This becomes 2 into 2125. The addition of 750 plus 750, 1500. 1500 plus 625 become 2125. This product is coming out to be, this will be 50, this will be 4250 centimeter square is the total area of the glass required to make this cuboidal herbarium. First answer. Length of the tape for all 12 edges. So length of tape is how much? Because tape will be fixed on all 12 edges, because length of tape is equal to total perimeter, that is 4 lengths plus 4 breadths plus 4 heights. That become 4 into L plus B plus H, coming out to be 4 into length 30, breadth 25, height 25. So this become 4 into 25, 25, 50, 50 plus 30, 80. 80 into 4, this become 320 centimeter long tape is required to put the tape on all 4 edges. Next example, where I am taking the application of the surface area and how to find the cost. Question is, the length, breadth and height of a room are 5 meter, 4 meter and 3 meters. A room is 5 meter long, 4 meter wide and 3 meter high. Find the cost of whitewashing its 4 walls and ceiling at the rate of rupees 7.50, that is at the rate of rupees 7.50 per meter square. So first of all, we should know that what area is to be painted. As clearly given in the question, that all 4 walls including the ceiling. These 5 surfaces are to be painted, that is floor is need not to be painted. So what we will do, first we will calculate the area of these 5 surfaces, that is what, area of 4 walls plus area of ceiling. To calculate the required area, that is area of 4 walls plus area of ceiling, I will write here length is given as 5 meter, breadth is 4 meter and height is 3 meter. Length is 5 meter, breadth is 4 meter and height is 3 meter. Required area is required area is equals to area of 4 walls plus area of ceiling You know that area of 4 walls is given by 2 into height into length plus breadth, and area of ceiling is always same the area of floor. So area of floor is length into breadth. If I substitute the values of length, breadth and height, 2 into 5 into length plus breadth, 2 into height is 3, into length is 5, breadth is 4, plus length into breadth 5 into 4, result is coming 6 into 9 plus 20, that is 54 plus 20, 54 meter square is the area of 4 walls, 20 meter square is the area of ceiling. This answer will come out 74 meter square. Cost of painting 1 meter square is rupees 7.50. So cost of painting the required area, cost of painting of which area? Required area is how much? 74. So this become rupees 7.50 into 74, rupees 7.50 into 74. This product will come rupees 555. So answer is, that is the cost of painting of the 4 walls with the ceiling at the rate rupees 7.50 is 555. Find the surface area of a cube if its diagonal is 4 root 3 meter. In fact, the formula for calculating the length of the diagonal of a cube is side into root 3. Let side of cube is x meters. So length of its diagonal, is side into root 3. This implies x root 3 is equals to 4 root 3 as per question. We have assumed the length of the side of the cube is x meter. Therefore, the length of diagonal is side root 3, or you can say x root 3. But the value of the length of the diagonal in meters is given as 4 root 3. This become x root 3 is equal to 4 root 3. This implies x is equals to 4 meters. That is, you can say side of the cube. Side of cube become 4 meter. So its surface area is 6 into side, that becomes 6 into 4 into 4, that becomes 6 into 16, that become 96 meter square will be the surface area of that cube whose length of diagonal is 4 root 3 meters. Now I want to take one more problem based upon the surface area concept. three equal cubes. We have three cubes which are equal in size. Three equal cubes of the same size are placed adjacently in a row. Find ratio of total surface area of new cuboid. If I will place three cuboids in a row, then what will form? A cuboid will form. Then they are asking find the ratio of total surface area of new cuboid to the sum of the surface areas of three cubes. Let each side of each cube is x units. If I have three cubes, each having the side x units, and these three cubes are placed adjacently, then what is going to happen? The new shape whatsoever will form will be a cuboid. That will be a cuboid, and the size, that is the length of cuboid, length of the cuboid so formed will be 3x, x plus x plus x. Then breadth of cuboid will not change, that will be x, and height of cuboid will also not change, will remain x units. Now the question is how to find the surface area of a cuboid. This will be surface area of cuboid formula, you know, 2 into length into breadth, that is 3x into x, 3x square, breadth into height, x square, height into length, 3x square, 3 plus 3, 6 plus 1, 7, 2 ja 14x square unit is the surface area of the cuboid so formed. We want to find the ratio of this area to the area of three cubes. Area, that is surface area of one cube is equals to 6 into x square. Surface area of three cubes is equal to 6x square into 3, that is 18x square. Now we want to calculate these two ratios. So I will write here required ratio of surface areas of the cuboid so formed to the surface area of three cubes is equals to 14x square is to 18x square. Its simplified form will be 7 is to 9. Now one of the very important question related to the surface area of the cuboid. It is find the surface area of a cuboid if sum of length, breadth and height, that is L plus B plus H for a cuboid is 12 meter, and the length of diagonal means root of L square plus B square plus H square is given 5 root 2 meter. This is equation 1, this is 2. What is required? We want to calculate the surface area of the cuboid if length plus breadth of plus height for the particular cuboid is 12 meters and the length of diagonal is 5 root 2 meter as given. Now if I ask you to square equation number 1, on squaring equation number 1, this will be L plus B plus H whole square is equals to 12 whole square. This become L square plus B square plus H square plus 2 into L into B plus B into H plus H into L. This is L into B plus B into H plus H into L is equals to square of 12 is 140. For here I have applied the formula of A plus B plus C whole square, A square plus B square plus C square plus 2 into A into B plus B into C plus C into A is equal to 144. If I ask you to square of equation 2, On squaring equation number 2, this will be L square plus B square plus H square left hand side. Square of 5 root 2 is what? 50. 5 5 ja 25, 2 ja 50. This is relation number 3 and this is 4. In equation 3, in place of L square plus B square plus H square, we can write 50. If this value of L square plus B square plus H square from equation 4 is put in 3, then it will be 50 plus. You know 2 into L into B plus B into H plus H into L is what? Surface area of cuboid. Surface area of cuboid is 144. Hence, on solving this, we will get that surface area of cuboid is 144 minus 50, that is 94 meter square. So, bit of the algebraic identity was required, a little bit replacement, and directly we can calculate that surface area of this cuboid is 94 meter square. One problem based upon the volume. A river 3 meter deep and 40 meter wide is flowing at the rate of 2 km per hour. How much water will fall into sea in 1 minute? Here the speed of the water is given in kilometer per hour, where the depth and width of the river is given in meter, and the water is required of the time 1 minute. So we need to very conscious about their units. So first of all, I want to tell you that length of water flowed in 60 minutes. In place of 1 hour, I can write 60 minutes. Is how much? 2 kilometers. I have to write this 2 kilometer as 2000 meters, because 1 kilometer is 1000 meter. So 2 kilometers are equal to 2000 meter. That is, water from here to here in the river is moving how much? In 1 hour it is moving 2000 meters. In how much time? 1 hour. So length of water flowed through this river in 1 minute. Length of water flowed in 1 minute. In meters, this is 2000 upon 60, because 1 hour 2000 meters. So you can say in 1 minute it is 2000 upon 60, which will come out equal to 100 upon 3. On simplification, 200 upon 6, 100 upon 3 meter. Breadth of river is given equal to 40 meter, and depth, which can be considered as the height. If I consider this is a cuboid, is 3 meter. So volume of cuboid is given by length into breadth into height, which is coming out to be length 100 upon 3, breadth 40, and the height is 3. So this result, when 3 and 3 get cancelled, comes out to be 4000 meter cube. Hence the conclusion is, if river is flowing at the rate of 2 km per hour, then width 40 and depth 3 meter, then the water which will be given to sea by the river in 1 minute will be 4000 meter cube, as all details and regions are given you. One more problem. A solid cube of side 12 centimeter. We have a big solid cube whose each side is how much? 12 centimeter. A solid cube of side 12 centimeter is cut into 8 cubes. This solid cube is divided into 8 small cubes, all of same size. Find the number of cubes. I am supposing, let side of a small cube is x centimeter. Side of the small cube is x centimeter. Number of cubes cut. How many cubes have been made? That is 8 small cubes. That is 8. So there will be one thing same. Volume of big cube will be equal to volume of 8 small cubes. Volume of one big cube is equals to volume of 8 small cubes. One big cube is 12 into 12 into 12 is equals to 8 into small is x cube. So x cube is equals to 12 into 12 into 12 upon what? 8. So answer of x cube is 216. Hence x is equals to 6 centimeter. So we can say that here find the, in place of finding the number of cubes it is given, we have to find the side. Find the side of cube. Also find the ratio between their surface areas. How to find that ratio of surface area? Surface area of the big cube is surface area of big cube. It will be 6 into 12 into 12, and surface area of a small cube will be 6 into side square. Side is also 6. So ratio will be, ratio of surface areas will be 6 into 12 into 12 upon 6 into 6 into 6, that is 4 upon 1, or we can say it is 4:1. Hence a solid cube of side 12 centimeter, when it is cut in the 8 small cubes of the same size, find the side of cube, that is 6, and find the ratio between their surface areas, that ratios are 4:1. The areas of three surfaces of a cuboid are x, y and z square units. Then prove that the volume is equals to root of x into y into z. I want to tell you, if there is a cuboid and there are 6 faces, out of these 6 faces 2 are identical. 2 are identical. Area of the first face is x, area of the second face y, and third face z. I am taking here, let the length of what? Cuboid is L. Breadth is, I can say in place of L, A, breadth is B, and height is C. So answer of x is length into breadth, that become A into B. Y, second face, area of the second surface is breadth into height, that is B into C. And Z, third surface, it is H into L, is C into A. Now x into y into z. X means A into B, x means A into B, x means A into B, y means B into C, and z means C into A. So x into y into z become ABC whole square. A is length, B is breadth, C is height. So x, y, z become volume whole square, because length into breadth into height is volume. You know that volume is equal to LBH. So volume become ABC. We know that volume is equal to LBH. So volume become ABC. Here in place of ABC I have replaced volume. As volume square is XYZ, so you can say volume is equal to root of XYZ. This is a required result what we need to show. One combined question where surface area and volume both will be used. If V is the volume and S is the surface area of a cuboid of sides A, B, C, that is length A, breadth B and height C units, then prove that 1 upon V is equals to 2 upon S into 1 upon A plus 1 upon B plus 1 upon C. This is volume is equals to length into breadth into height. So volume become A into B into C. Now the left hand side will be 1 upon V, which will be 1 upon A into B into C. We can call it relation number 1. Now if I talk about right hand side, here you know that right hand side is 2 upon S into 1 upon A plus 1 upon B plus 1 upon C. Here S stands for surface area, and you are very much sure about the surface area of a cuboid is given by 2 into what? Length into breadth plus breadth into height plus height into length. That is A into B, length into breadth plus breadth into height, B into C plus C into A, that is height into length. Now LCM of this part is A, B, C, and here we will get A when cancelled BC plus CA plus AB. You can observe these two can be cancelled, 2 can be cancelled, we can get 1 upon ABC. So left hand side is 1 upon ABC, the value of the right hand side is also showing 1 upon ABC. So what conclusion we can draw? For a cuboid having volume V, 1 upon V's answer will be equal to 2 upon S times of 1 upon length plus 1 upon breadth plus 1 upon height. The proof is shown here, that is left hand side is what? Length into breadth into height, volume ABC, and it is 1 upon V means 1 upon ABC. Right hand side is required as 2 by S multiplied by 1 upon A plus 1 upon B plus 1 upon C. Value of surface area in case of the cuboid is given by 2 into AB plus BC plus CA, and after taking LCM we are getting the numerator of this component as same. So simplification is this giving 1 upon ABC. So answer of 1 upon V is 1 upon ABC, and answer of right hand side is also 1 upon ABC. So conclusion comes that in case of cuboid this relation holds true.